welcome to this lecture video. In this video, I am going to explain problems of elastic properties of materials, which comes under module number 2 of engineering physics prescribed by VTU. So here I am going to explain the following problems. So the problem number 1 is calculate the angular twist of a wire of length 0.3 meter and radius of cross section 0.22 into 10 to the power of minus 3 meter when a torque of 5 into 10 to the power of minus 4 Newton meter is applied. Rigidity modulus of the material is equal to 8.2 into 10 to the power of 10 Newton per meter square. So as per the problem, the given data is L is equal to 0.3 meter, R is equal to 0.22 into 10 to the power of minus 3 meter, and rigidity modulus N is equal to 8.2 into 10 to the power of 10 Newton per meter square, and torque T is equal to 5 into 10 to the power of minus 4 Newton meter. So here we have to calculate the angular twist theta. So as according to the formula, the angular twist, that is theta, is given by, so torque T is equal to C into theta. So the value of C is found to be pi n r to the power of 4 by 2L. Therefore, the value of theta is given by 2TL by pi n r to the power of 4. Now substitute the value of TL, n and r to the power of 4 here, that is 2 into 5 into 10 to the power of minus 4 into 0.3 divided by pi into 8.2 into 10 to the power of 10 into 0.22 into 10 to the power of minus 3 whole to the power of 4. So on calculating all these, we are going to get the value for theta is equal to 0.497 radian. So this is what the value for the angular twist after calculating the values. The next problem is problem number 2. A brass bar of length 1 meter and 0.01 meter square in section is clamped firmly in a horizontal position at one end. A weight of 1 kg is applied at the other end. What depression would be produced when the Young's modulus of the brass is equal to 9.78 into 10 to the power of 10 Newton per meter square? So this is what the problem. So here the given data is L is equal to 1 meter and B into D, that is breadth into thickness, is equal to 0.01 meter square. So here B is equal to D, that is equal to 0.1 meter, and F is equal to W, that is equal to 1 kg, and the weight will be nothing but 1 into 9.8, that is mass into acceleration due to gravity, that is 1 into 9.8, so many newtons. And the Young's modulus is taken as 9.78 into 10 to the power of 10 Newton per meter square. So what is the value of H here? That is how much depression will be produced because of the load applied. So we know that the depression H is given by 4W by YB dq. So substitute the values in the formula, that is 4 into 1 into 9.8 into 1 cube divided by 9.78 into 10 to the power of 10 into 0.1 into 0.1 whole cube. So these are all the parameters substituted. So after calculation, we are going to get the value for H is equal to 0.008 into 10 to the power of minus 6 meter. So this is what the data we are going to get after calculating this. Next, the problem number 3. An increment in length by 1 mm was observed in a gold wire of diameter 0.3 mm when it was subjected to a longitudinal force of 2 newtons and a twist of 0.1 radian was observed in the same wire when its one end was subjected to a torque of 7.9 into 10 to the power of minus 7 Newton meter, while its other end was fixed. Calculate the value of Poisson's ratio for gold. So we have to calculate what is the value of sigma or Poisson's ratio. So here as per the problem, the given data delta L is 1 mm, that is 10 to the power of minus 3 meter, and the radius is diameter by 2, that is 0.3 by 2, that is equal to 0.15 millimeter or 0.15 into 10 to the power of minus 3 meter. And here the force F is equal to 2 Newton and the angle of twist theta is 0.1 radian and torque applied is 7.9 into 10 to the power of minus 7 Newton meter. So we have to calculate sigma or Poisson's ratio. So we know that Young's modulus Y is equal to Fl by pi delta L r square and C is equal to T by theta, and further rigidity modulus N is equal to 2Lc by pi r to the power of 4. So by doing Y by N we will get F theta r square by 2T delta L. So after substituting the value of F, theta, R and T and delta L, that is 2 into 0.1 into 0.15 into 10 to the power of minus 3 whole square divided by 2 into 7.9 into 10 to the power of minus 7 into 10 to the power of minus 3. So by calculation we are going to get the value of Y by N as 2.848. Now we know the another formula, that is 2 into 1 plus sigma is equal to Y by N. So the value of sigma can be written as 1 by 2 into Y by N minus 2. So substitute the value of Y by N here, that is half into 2.848 minus 2. So on simplification, the value of sigma is equal to 0.424. So this is what the value of sigma that we are calculated here. The fourth problem is a wire of length 2 meter and radius 2 millimeter is fixed to the center of a wheel. A torque of magnitude 0.0395 Newton meter is applied to twist the wire. Find the rigidity modulus of the wire if the angular twist is 0.038 radian. So as per this problem, the given data is L is equal to 2 meter, R is equal to 2 into 10 to the power of minus 3 meter, and torque T is equal to 0.0395 Newton meter, and the angle of twist theta is equal to 0.038 radians. So here we have to calculate what is N or rigidity modulus of the wire. So we know that torque T is equal to C theta, further C is equal to pi n r to the power of 4 by 2L. So by making use of this equation, we will get the value of rigidity modulus N as 2TL by pi theta r to the power of 4. So substitute the value of all the parameters, that is 2 into 0.0395 into 2 divided by pi into 0.038 into 2 into 10 to the power of minus 3 whole to the power of 4. So substitute all the parameters. After calculations, we are going to get the value of rigidity modulus N as 8.272 into 10 to the power of 10 Newton per meter square. So this is what the data that we are calculated by applying the formula. Next problem is calculate the twisting couple on a solid cylindrical rod of length 1.5 meter and radius 80 mm when it is twisted through an angle of 0.6 degree. Rigidity modulus of the material of the rod is 93 into 10 to the power of 9 Newton per meter square. So here as per the problem, the given data is L is 1.5 meter, R is 80 into 10 to the power of minus 3 meter, and the twisting angle theta is 0.6 degree. If you convert that into radians, so multiply by pi by 180, so 0.6 into pi by 180, so many radians, and then N, that is the rigidity modulus, is 93 into 10 to the power of 9 Newton per meter square. So here we have to calculate what is twisting couple, that is C. So using the formula, twisting couple C is equal to capital C by theta, couple per unit twist. So couple per unit twist C is given by pi n r to the power of 4 by 2L. Therefore, the value of small c is equal to pi n r to the power of 4 by 2 theta L. Now substitute the values, that is pi into 93 into 10 to the power of 9 into 80 into 10 to the power minus 3 whole to the power of 4 into 180 by 2 into 0.6 into pi into 1.5. So this is what the substitutions. So after simplification, we are going to get the value for C as 3.81 into 10 to the power of 8 Newton meter per radian. So this is what the value of C that we are calculated. Now the problem number 6 is a wire of length 2 meter and radius 0.2 into 10 to the power of minus 2 meter is fixed to the center of a wheel. A torque of magnitude 0.0395 Newton meter is applied to twist the wire. Find the angle of twist. Given the rigidity modulus of the wire is 8.3 into 10 to the power of 10 Newton per meter square. So this is what the problem. As per the data available in this problem, the given data is L is equal to 2 meter, radius R is equal to 0.2 into 10 to the power of minus 2 meter, and then rigidity modulus N is equal to 8.3 into 10 to the power of 10 Newton per meter square, and torque T is equal to 0.0395 Newton meter, and here we have to calculate what is the value of theta, that is angle of twist. So we know that torque T is equal to c theta, further C is equal to pi n r to the power of 4 by 2l. So we get the value of theta as 2tl by pi n r to the power of 4. Now substitute the values, that is 2 into 0.0395 into 2 divided by pi into 8.3 into 10 to the power of 10 into 0.2 into 10 to the power of minus 2 whole to the power of 4. On simplification, we are going to get theta as 0.0379 radians. So this is the value of angle of twist, that is theta. Thank you.